10.4 notes, polar coordinates graphs, page 5. So example 7 here, we are looking at cardioids. And you notice that there are 4 different ways to get cardioids. We've got formulas here, r equals a plus b cosine theta, r equals a minus b cosine theta, r equals a plus b sine theta, and r equals a minus b sine theta. Again, the cosine and the sine are just going to let us know whether we are oriented and symmetric across that polar axis, the x-axis, if you will, or the line theta equals pi over 2, the vertical axis or y-axis. So we have a reference at the bottom. We're going to ignore those for now and make sure our graph looks the way it's supposed to by going through these steps. Now, these are the ones that came right out of the text. I will be honest with you, once I get used to what some of these graphs look like, I will ignore the whole check for symmetry part, just because sometimes it feels like more work than you have to do. But for now, this first one, we're going to go ahead and go through their steps. So we're going to start by checking for symmetry. So here's one. We've got symmetry with respect to that line theta equals pi over 2. And so we're going to replace our r theta with negative r negative theta and see if we get an equivalent expression. This gives us negative r equals 2 minus 2 cosine negative theta. But since cosine is an even function, that's the same as positive cosine theta. Moving that negative off the r and onto the other side, we get negative 2 plus 2 cosine theta. So this one is a fail. This does not reflect across that line theta equals pi over 2. So now we're going to look at the polar axis. So with respect to the polar axis, and here we're going to replace r theta with r negative theta. I get r equals 2 minus 2 cosine negative theta. We just talked about the fact that cosine is an even function. So this becomes 2 minus 2 cosine theta. So this one's a yes. This is going to be symmetric across the polar axis. And now we're going to look about symmetry with respect to the pole. And so we get that by replace CE. R theta with negative r theta. I get negative r equals 2 minus 2 cosine theta. Don't know what happened there. And we already showed that that situation was a fail. Okay, so we're looking for this to reflect across that x-axis, that polar axis. Two. It says find the zero. So we're going to set r equal to 0. And I'm going to add 2 cosine theta to both sides. And then we get cosine theta equals 2 over 2, which is 1. And we know that cosine theta is 1 when theta is 0 or 2 pi. So I know I've got r is 0, theta is 0. It's going to be a point on my graph. R is 0, theta is 2 pi. Is going to be another point on my graph. 3 asks me to find the maximum value of the equation. So to find the maximum here, I know that cosine is trapped between negative 1 and 1. So it's either going to be cosine equals 1 that makes this a maximum, or cosine equals negative 1 that makes this a maximum. So I can I can plug them in. Cosine 1, I get 2 minus 2, which is 0. 2 minus 2 times negative 1, which would be 2 plus 2, which gives me a 4. And so I want to, that's definitely my maximum. I want to figure out where the cosine is negative 1. We know that happens when theta is pi. So cosine of theta is negative 1 when theta is pi. So I know that this point for pi is also on my graph. Okay? And so now I'm going to make a table. And because I like being able to show the work, I tend to make them this way. So we plugged in 0. We already know we get 0, but I can write that out. 2 minus 2 times the cosine of 0, which is 2 minus 2 times 1, which is 0. I'm going to pick the values that are a little easier to work with. So I'm going to skip pi over 6 because I don't really want to have to deal with that square root of 3 over 2. But I get 2 minus 2 times the cosine, of pi over 3. 2 minus 2 times 1/2, which is 2 minus 1, which is 1. Oh, I guess I got a little more room there than I thought. 2 minus 1. I'm going to pick up pi over 2 because cosine there is 0. So I get 2 minus the cosine of pi over 2. Oops, 2 times the cosine of pi over 2. 2 minus 2 times 0, which is 2. And pick up 2 pi over 3. Because I know my cosine there is negative 1/2. 2 plus 1 gives me a 3. At pi, we already know we have 4. And that's the top half of my circle. I know this is going to reflect, but just to be safe, I could take a look at 4 pi over 3. Cosine at 4 pi over 3 is negative 1/2. I get that 2 plus 1 again, which is 3. I can go 3 pi over 2. 2 minus 2 times cosine is negative 1 there. Cosine is 0 there. Just making stuff up now. 2 minus 0 is 2. And I could go 5 pi over 3. 2 minus 2 times a positive 1/2. 2 minus 1 is 1. And then we know from above that 2 pi, we're back at 0. Okay? So let's go ahead and graph this and see what this looks like. Keep in mind, we're looking for that cardioid shape. It should look like a circle that's kind of got a dimple in it. So at 0, I've got 0. Actually, let's see if we can make this show up a little more. 0, 0, there we go. At pi over 3, it's 1. So pi over 3, I am at 1. At pi over 2, it's 2. 2 pi over 3, it's 1, 2, 3. And at pi, it's 4. And so we want to be able to connect these in kind of a curve shape. And I'm going to connect them in order without making it look like a straight line. Or an oval. That was not the point either. Okay. And now if we continue on to the bottom part, 4 pi over 3. I'm back at 3. 3 pi over 2 is 2. 5 pi over 3 is 1. And at 2 pi, I'm back at 0. And so here's the bottom half of our cardioid. Again, you guys, you're sketching here. All of these should be smooth curves, ignoring what mine looks like. Okay, really important to be able to match the way the equation looks with what type of graph you're getting. And this should be a little more rounded out here. I made it a little pointy. Okay, so notice something at the bottom. We've got r equals a plus b cosine theta. So that is symmetric across that polar axis with the cosine. Same with the r equals a minus b cosine theta. If b is positive, our cosine is positive, this orients to the positive x-axis or the positive polar axis part. If it's minus b cosine theta, we're looking at that negative cosine value or the cosine being subtracted, then it's oriented to the negative polar axis. Negative this way, positive this way. Same thing with the sine. A plus b sine theta, it's oriented to the positive y values, so the positive vertical direction, and r equals a minus b sine theta, we've got that cardioid mostly on that negative side. One other thing to notice, and I kind of glossed over this, cardioid graph always passes through the pole. Notice that because a and b are the same value, that as soon as that cosine or sine equals 1, you've got a basically minus a, or a plus a. And so we are always going to go through the pole for a cardioid.